Hello and welcome to this feature spotlight video on scripted scenarios within Test Runner for Emulate 3D. I'm Andrew Diebel, the product manager for Emulate 3D, and we're going to look at one application for Test Runner today. Test Runner lets us compare and validate different model setups against each other. Now, we could be comparing different machine layouts to see which produces the best throughput. Or we could be putting our controls code through its paces with a virtual FAT. Or in this case today, we could have changed a model or a catalog and we want to run some automated tests to ensure that it works how we want it to work. This video follows on from the last feature spotlight on using Git version control for catalog creation, so we recommend that you watch that first if you have not done so already. So there's really another step we want to take after every commit that we make, and that is to run our automatic tests. And the new Test Runner feature is fantastic for this. You can load up Test Runner inside Emulate 3D to perform tests and watch them run inside the user interface. But you can also run Test Runner as a completely separate application which will run Emulate 3D headless. Basically means that you won't see the user interface, you won't see your model run, but it's just going to load up behind the scenes on your computer and give you this dashboard of results out. Test Runner has a lot of different applications which we're going to cover in future feature spotlight videos. Now we're going to use Test Runner here with the scripted tests options, and this is fantastic for making sure that our catalog components and scripts are going to behave consistently. We can create these scripts which run with all the flexibility that Emulate 3D C# scripting provides, and run them every time we make a commit to make sure our behavior is consistent and we haven't accidentally broken a feature by making the last change. So let's have a look at a couple of different examples of what this might be like. We've got some tests here that are going to create a small assembly, including the Singulator and some in-feed and out-feed conveyors and load creators. It's going to configure them to create loads at a certain rate, and it's going to check to see that all of the loads are going to pass through our system and reach the other side. So here we've got a test that's going to run a batch of 20 loads through the system. And if we run the scenario, we can see that a new assembly is created, the loads run through, the model cleans itself up, and we get a result. Our test has passed. We can try to stress our test system out a little bit more. Why don't we run 100 loads through the system? We run the test, lots of loads pass through the system. You can see that it all runs smoothly, it doesn't get clogged up, all of the loads reach the end, and then our test concludes. What about something a little bit more stressful? What about 100 loads through the system at a high in-feed rate? Well, in this case, we run, and our Singulator can't handle this throughput, and it clogs up given its default settings, and our test identifies this. We've set up something called assertions that inspects the model at various points during the test, and it tells us if we pass and fail. Here we can see that we expected 100 loads through the system, but we only actually got 77 through because it got clogged. Now, scripted scenarios are fantastic for experienced users of Emulate 3D who are comfortable in C# scripting because of the flexibility that they provide. Note that you could also create these scenarios manually by using the user interface with this test scenario section, and we'll cover that in a future feature spotlight. The scripted scenarios allow us to do some really quite complex things, like, for example, adding an object into a model, changing properties, and checking that we get the right behavior. So this test here is going to add our Singulator into the model, and it's going to mirror it using the alignment side property. This test just here is going to add the Singulator into the model, and it's going to change the height of that recirculation. This test will change the balance between the incline conveyor, bringing it back up, and the angle of the deflector. And all of this is really easy to set up using the underlying NUnit framework, which the Test Runner uses to run these scripted tests. Let's have a little look at how this works, and we can make a small example. So let's bring up the script which creates these tests behind the scenes. You can see that our test script has to have a few prerequisites in order to make use of the test runner itself. We need to inherit from the test fixture, we need to ensure that we're using the NUnit framework and the Demo 3D test runner, and then we need to set up our test classes using this Emulate 3D test attribute. Let's make a small example, and then we'll explain some of the more complex ones. Let's create a test that adds one of the singulators into the model from the catalog and check that the script compiles. So we're going to create a new task, which we're going to call can create singulator. And then we're going to give this the attribute emulate 3D test. Our test is going to make one of these singulators. So we're going to add it from a catalog by name. So we'll say var singulator equals document create visual, and we'll get it by name. And then we're going to do an assertion using the assert class. This is our check. We're going to assert that our singulator is not null. Fantastic. That's our whole test. Can we create it? And can we check that it's not null? So when we save our script and go back into Emulate 3D, when we recompile, we will immediately see a new test being added to the top of our scripted tests in Test Runner. This can create singulator, and that's because we had that attribute on our new method. And when we run it, quicker than we can see, it was added to the model and our test passed. Let's make our test slightly more complicated. Let's go and run the model for a period of time and check that change we made earlier. Let's maybe see if we can go and make that logo visible and invisible and see if that actually works, that change we made. So if we want to run the model, there's a few ways we can do this. I like to use the run model 4 seconds asynchronously. And this lets us run the model for a period of time and then run more code afterwards. So we can run it for 3 seconds, and then we can choose the run speed. So the run speed is going to be at 1 times speed. Okay, after we run it for 3 seconds, let's do something. Let's change something in the model. Let's do Singulator. Let's set our custom property. And the custom property we're going to set is our show E3D logo. And we're going to turn it off. And then finally, let's do another assertion. We're going to assert that our logo, which we can find by name by doing document find visual E3D logo. Let's check it is visible. We want to make sure that's actually false. So we can use this assert class, which has loads of options, loads and loads of options. In this case, we're checking it's false. But this was numeric. We could check it's between bounds. We could check the two objects are equal, all the things that we would expect. In this case, we can actually put an assertion message. So if it isn't false, we can put a message in to say, uh-oh, logo was still visible. And then if our test fails, this is the message we'll receive to tell us exactly what happened in that test failure. So let's save the model. Let's go back. And here we can see created the singulator, we're running for 3 seconds, and then everything disappeared. It seemed to pass, but I would have liked to have seen that logo disappearing as the model is running. It's kind of a visual validation that my test did do exactly what I wanted. So to show you another nice technique, we're going to queue up an action. We're going to queue up actions that take place while the model is running. And these actions can be quite complex. It's just any method that you set up. We're going to make this really quickly. We're going to run an action at time. At 1 second in our model run, that is when we're going to run our change here. And then we'll queue this up, run the model, and then make our checks. Save, go back into Emulate 3D, run our test. There he is with the logo. The logo's disappeared. I'm happy. And the test has passed. Using these techniques, we can really quickly build up a series of tests. So here, using reusable methods to test batches of loads, we've got some logic which creates a parcel singulator, some conveyors, some load deleters, some load creators, run the models, and performs these checks. And then in our configuration tests, we're changing properties on our object, and we're checking that the actual dimensions of objects have changed to what we expect them to be. We also have some tests that check the alignment of the loads as they run through the system, various loads coming in at various skew angles, and we just check that they're coming in at a nice kind of squared off 90 degrees as they leave that parcel singulator. And another little tip, you can use the attribute one-time setup in order to perform an action before you run a single test or a batch of tests. In this case, we want to make sure that we have our loads catalog open and our conveyors catalog open, and the model is reset and ready to test. We can also perform a teardown action that lets us clean up ready for the next test, and that's going to save on the code for our tests themselves. The power of C# scripting, combined with Emulate 3D's open and comprehensive APIs, gives us a huge amount of flexibility to create basically whatever tests we want for our catalogs and scripts, including things like testing custom user interfaces. We have to be a little bit careful though, as we're accessing the model and user interface from a separate thread. For this particular example method, everything was okay because we interacted with the model whilst it was stopped. And when the model was running, we made sure we queued up the action using this run action at time method. If we want to interact with the user interface, if we want to change properties or read properties whilst the model is running, and if we just generally want to do things in a safer way, we can use this model action to keep things safe. It's going to make sure that the action is put on the right thread and everything behaves correctly. So this is the safe way of making our tests. So if we combine version control with automated testing, then we get modern software style development practices. It's going to produce better quality, easier to maintain catalogs for us all. We can also apply these same techniques to model builds, and this is what we're going to look at future feature spotlights. How we can use the test runner for our simulation models and for our virtual commissioning models.